So this is the two magnets. Again, you know that normally it is going from north to south, right? This is kind of the the field that you will see north to south. Same thing here, north to south, right? Here. These two, see that here? These two kind of are against each other. This is for this direction to this direction. Kind of they are repelling. These two magnetic field interaction is repelling because they are against each other. And you will see some space there. Here is that. For this one again, you will see north to south. I'm just going to put a few of that here. Here is north to south. I'm going to put that north to south. North to south, right? Okay, just this one. North to south. Okay, I'm gonna just say one more time. Uh, Again, you know that when we had this is the north, and here is, let's say, south, right? Here is south. Kind of, they will be, okay, just, where is this? Huh? Normally, this is like that, right? Okay. Uh, we know that the north and the south pole, they will be attracted to each other, right? And when it do, these two poles, kind of these two lines come together. How? It's kind of, it become like this, okay? And then maybe I just make it better. That a little bit like this. And then just like that, okay? But you know, few of that will be attracted, so you will get that pattern. I'm gonna correct myself here a little bit. So again, they are kind of against each other here. So few of that will be joined there. Kind of, they are kind of need to attract each other, right? This and this need to attract each other, S and north, right? So that's why these two, few of them, not all of that, will join and come together. And that would be something like this, right? Few. Same thing, these two attracting, again from north to south, right? And then I will have, oops, the rest going north, south. Okay, so something like that. I just draw a few, not all of this. Okay, the same thing happening here. Look at that. This is north and south, right? Few of that will be connected because they are against each other, but will be connected. If I want to do this, it's hard to draw, but I try my best. So I will have a few line like this connected to that, going from north to south, right? And then the rest of that would be the same, right? So something like that happening. And again, um, if I want to do this, see they are opposing charges, so they will be attracted. Where's my eraser? Where's the eraser? Seriously. Okay. Few of that will be attracted. I'm just putting two of that in from north to south, and then the rest will be like normal. That, right? That way. And looking at that, they will really repel, right? This, so they will repel and they will kind of not be connected. I'm gonna just put one things here for that side. Perhaps it's not gonna be connections here, but that would be the pattern that we would see. Something like that, okay? Between these two are attraction and between these two are repulsion. And that would be 3D, right? I cannot draw a 3D for you, but just put a few lines and just tell you what's the idea. Now, also principle, I want everyone to participate when I'm just doing this, and maybe I need to demonstrate that for you. You need to try it and make sure you can perform that on your own, okay? Now, we want to introduce you to the right and left hand rule to determine the current flow or magnetic field direction. So these are Oersted law that we need to do right now. Now let's just go through the Oersted principle and then we will, after these two slides, we will do practice that by hand, okay? Together. So with electromagnetic, we are interested in the movement of electron through a conductor. So what does it mean? So you have a conductor, like what? A wire. An electron is moving, right? The wire. And this is the direction of the movement of electron. But when we are talking about this principle, we thinking that the positive charges are moving. So conventionally, if the electron moving in this direction, then we could say positive charges moving in opposite direction. So now that is the conventional current that I'm gonna talk to you about. That's why we use the right hand for this. Right hand. If you're talking about the conventional current, and if we do not want to talk about conventional current, we need to use our left hand. Okay, but I'm gonna ask you just use your right hand because always you see the direction of the current. I'm putting the direction of the conventional current, right? Okay, charge moving through a conductor produces a circular magnetic field around the conductor. So this is, let's say, my current going in this direction, right? I call it like an I in this direction. And this will produce a magnetic field and it's going to be like a circle around that. Maybe I just open my, and you can see me, and I'm going to demonstrate this for you. You want to see me? Okay. If this pen is that wire, this is my thumb, right? Everyone just grab a pen, bring it up. This is my thumb. my right hand. I use my right hand because this is a conventional current. I put my thumb into the direction of the current, which is the current going to left. Okay, this is my wire. This is my thumb. My hand is bending, right? Bending like this. My forefinger bending like that, right? So it's going into the page and bending and going something like that. If I want to draw the result I just perform on this paper and the things that you have to do in your test, that would be like that. My Again, my thumb will be in this direction. This is my thumb. My forefinger will bend like that. Okay, that's my best I could do. So that would be, this is my right hand again, so that would be that. So it's kind of, we have a magnetic field in this direction. Okay, I'm gonna perform one more time. Let's just move on to this. Now again, conventional current we will talk about. You would expect the electron to flow from an area of the high to low voltages, right? But in physics, we want to talk about the conventional current. See, conventional current is from positive, the highest, to the lowest, right? So that would be the conventional current. But actually, this is the electron going from negative to positive, right? This is the electron flow directions. I did talk to you about that, and this is the law that I did talk to you. I did the other direction, now we're doing the opposite direction here. See, the current now going to the right. Again, I have this, my thumb, right? My thumb going to the direction of the current. My forefinger will be bent. So now my forefinger will get out of the page, kind of, if I have that page. That's like my pen there, right? I want everyone try it. I'm gonna give you 2-3 minutes that you try to do it and put this direction. If this is going out of the page, this circle that we put here, that would be is from here to here. You know, in front of the wire, my finger need to go down. Okay? If you try it correctly using your right hand, in front of the wire, my finger need to go down. Do you see that in front of that? This is going down. Just gonna draw that here for you. This is the circle in front of the wire is going down, and back of the wire it's go up. So you really need to get that. Back of the wire is go up, but in front of that your finger goes down when you make that circle. Try that, give you 1 minute, and if you cannot, I need to explain more explanation. Uh, you have to speak to me right now, right away, and maybe I help you more. Okay?
Yeah, can you explain it more a little bit?
Okay. So, Jessica, I want you to try and follow my instruction, okay?
Okay, okay.
Get a pen or pencil, wherever you have.
Done.
Put your finger to the direction of the current. Now the current here going to the what? To right on that picture. True?
If it's going, so do I hold it with my right hand or left hand?
Right hand, because we're talking about the conventional current. Conventional is positive charge. Positive charge, your right hand, okay?
Okay.
So, did you do that? Your thumb follow the pencil to the right.
To the left, no?
To the right.
My,
This is your
my,
finger to the right because the current is to the right, yeah? In a picture. Look at the picture.
oh, okay, now I see it. It's fun. Oh, okay.
Okay, good.
Yeah.
Okay, follow me. Your thumb to the right on that wire. Okay?
Mhm.
Now, what is happening? On the back, your finger is going up, right? On the back of the pen.
Yeah.
And when you bend it, means in front of the pen, your finger going down, true?
Uh huh.
So in front, your finger go down, at the back, your finger go up. See? This same thing. At the back, the circles, the direction of that is up, like your finger. And in front, the direction of the circle is down, right? Like your finger in front of that goes down. Got it?
Yeah,
Look
thank
at
you.
that. Is this one at the back, the finger is going up, and in front, the finger go down. Something like that. Okay, got it?
Miss, so like when would you know like when to use the right hand and like your left hand?
When we do the conventional current, we use the right hand, and all the time that you see in this course, I'm using the conventional current. Okay? If somehow the question said negative charge is moving, if it said negative charge is moving, you have to use your left hand to do all of this. Okay?
Okay, yeah. So can you like also explain like what conventional like current flow is and like why that like relates to like the fact that we have to use like the right hand rule?
Yeah. The conventional current, we're assuming that the positive charges is moving. We go back to this. See, the conventional current, we say the positive charge is moving, but I say actually, actually the negative charge is moving, right? The positive charge won't move. Uh, the negative charge is moving, but because the calculation is easier when we talk about the positive charge. If the positive charge is moving to the right here, it means I could assume that then if the negative charge is moving to the right, I could assume that is the same as saying positive charge is moving to the left. Okay, these two are the same situation, but I'm I do feel better when I work with the positive numbers. Okay, negative charge moving to the left to the right is the same as saying positive charge moving to the left. Okay. And when we're talking about the positive charge moving, you're using your right hand rule or using your right hand to do it. And all of those systems that we're solving, we are assuming that the positive charge is moving. Like this is conventional current again, is just from the positive, the higher voltage to the lowest voltage, right? This is what you see in a circuit, assuming that the positive charges is moving. Mhm. Okay.
Yeah, but in your diagram, you said like when the positive charge is moving, you drew like your arrow to like the left direction.
Mhm. So this is different example, right? Don't connect it to the example that we are doing right now. This is kind of the direction of the negative charge in this direction, so the positive direction gonna be in that direction. You know, if I'm gonna make another one because I think it might be confusing for you. If the negative charge, this is my negative charge, right? If negative charge moving in this direction is the same as saying the positive charge is moving in what direction? In this direction, true? If the negative charge is moving to the left, it's the same as saying positive charge moving to the right. And this is the example now we're trying to do. But this is a different example. This is not connected to what we do right now. Here, we're assuming that the positive charges is moving to the right. Okay? Because look at that, it's from positive to the negative. It means this is the direction of the conventional current, the direction of the positive charges. Okay? Is there any other question I can answer on that? That would be very important, and you can challenge me with your questions. Everyone got the right hand rule? Please, if you don't, you can open your mic to speak to me. Everyone got that rule? I hope so. Now, electron flow. Now, again, if we're assuming that the electron means negative charge is moving, you can use what? Your left hand. The same thing. Now I'm assuming that the negative charge is moving. See, this is from negative side of the battery to positive, means this is the direction of the negative charges. See? Again, this is my wire. I put my finger. I'm using my left because now this is a negative charge. Put your finger in the direction of the current, which is to the left. Now you're bending your finger. So your finger go up on the back of the wire and go down in front of the wire. Okay? So everyone can perform this and check. So at the back it's go up, and in front of that this circles goes down. You need to follow this direction, and you need to draw that direction for me. So as you see, it doesn't matter if we consider a negative charge is moving or positive charge moving. It's still the direction of the magnetic field at the back goes up, in front goes down, right? This example and this example is the same. In the first example, we're assuming that positive charge is moving. In the second example, we're assuming that negative charge is moving. True? If we follow the rule, we get the same result for magnetic field. Again, just not making you confused. Yeah? Anyone have
So for
question?
like the left hand rule, are you like using your right hand and pointing to like the left direction?
Okay, for right, okay. So just make sure. If you have electron, because the electron has negative charge, right? Electron has negative charge. Anything with negative charge, you have to use your left hand. Anything with positive charge, you use your right hand, okay? Any further question?
Yeah, but for like the diagram for like
Hmm.
the right hand rule, like it looks like the left hand is being used.
How do you know okay, you say, okay, can you repeat that?
Is it because like when we're supposed to do it, our palms are like facing like us?
Okay, just wait one by one. I'm gonna go to, I think the first person who was talking to me was Angelina, right? Or Jessica. I'm not sure who was talking to me. The first person. Let's say repeat your question.
Yeah, so I just meant like so for the right hand rule, like you're only gonna use your like right hand and like point to the left. Is that what you
Okay,
mean?
wait. Okay, I got you now. So for right hand your rule you're using for positive charge. But my finger could be to the right or left, depends on the situation, right? Right hand rule, maybe just write it down here for you. Good question. I like what you're challenging me with. So right hand your rule is for positive charge, okay? Is right hand rule. And depends on situation. If the positive charge moving to the right or left, I can adjust my thumb, right? If the positive charge moving to the right, I put my finger to the right. If the positive charge is moving to the left, I have to put my finger to the left. Mm-hmm. My finger could be in any point, but I have to use my right hand for positive charge always. Does that make sense?
Okay, yeah. So when you say like you're using for positive charge, that means like you're like assuming like the positive charge is moving and not the like
Exactly.
electrons, right?
Yeah. Assuming the part positive charge is moving. Yeah. Other question? That would be good. Actually, it could be other students' questions also. This who's talking? Is that Angelina or Jessica? I'm not sure. Okay. There was another person who was talking to me. Who was that? And please ask your question. I don't want to miss you. No one else have question on that? Okay. All right. So here, left hand, we did right hand. We did left hand for electron. When we assuming that electron is moving, you using your left hand, right? So looking at these wires, here is the convention to represent a wire coming in or out of a page. Okay, I'm gonna talk to you about this. And everyone need to follow my instructions. This for these two questions. I'm gonna do A first. When you do see something like cross here, means the wire going into the page, means the current, we have a wire like this. Just saying that. This is the into the page. Okay? The direction of the current is into the page. That's why, since this is conventional current, means positive charge is moving. Okay? Positive charge is moving. I need to use my right hand. I put my thumb in the direction of the current which is into the page. Now I need to see what is the direction of my forefinger. My forefinger gonna be clockwise or counterclockwise. So for me, it's kind of it is clockwise. My finger is bending like this, and I will see that this is going clockwise. I want everyone to try it. If you put your finger into the direction of the current, which is into the page, uh, your forefinger need to bend clockwise. Everyone, please try it. I'm gonna give you 1 minute. If you are not sure what to do, turn on your mic and talk to me right now. See, the direction of this magnetic field is clockwise, means your finger is bending toward the clockwise direction. Just allow 1 minute for you to perform that on your own.
Miss,
Yes, Stephanie.
earlier you said that like the position of your thumb depends on like the situation.
Mm-hmm.
Um, can you show what that looks like?
Okay, so here set the current going into the page. So I need to use my right hand because it's a positive charge. Okay. Now I need to put my thumb in the direction of the current, which is into the page. Do you see that this pen is my wire? And I'm just putting in a kind of into the page, something like that. Okay. And then I put my thumb in the direction of the current. Now follow the bending. My finger is bending clockwise, right? Was that clear or still not? Stephanie, got it? So you need to challenge me if you still need more help.
Can you explain again?
Sure. I'm gonna just put some drawing maybe because this kind of sucks when you're demonstrate things behind the screen, right? Okay. So this is my wire, right? Doesn't matter which direction it is. So I put my thumb, my right hand. I've just used my right hand. This is my thumb, okay? And this is my forefinger. I do have my forefinger. I put my thumb in the direction of the current. Okay, this is my thumb. And my forefinger is bending. Then I bend my forefinger. Oh, actually, just give me a second. I have to do it and perform it here. So this is my wire. I just put my thumb in the direction of that and see my hand need to bend. I want you to perform that, Stephanie. Do you have a pen or pencil?
Yeah.
Okay, grab it. Put your thumb in the direction of the current. Did you
Yes.
see your finger going up behind your pencil, right? That's it.
Yeah.
And when you bend it, it will your finger go down in front of the wire. Does it?
Yes.
Okay. So I'm gonna just draw this. Your thumb going to the that, your finger go up, and when you bend it, it go in front of that. So that would give you the direction of that magnetic field. So behind the wire, again, the magnetic field goes up, and in front of that, the magnetic field goes down. Okay, so this is how you draw things. Okay.
Wait, but miss, so like earlier you said like, um, depending on like which direction your conventional current is
Mm-hmm.
going, you like point your thumb that way, right?
Yeah.
So what I'm confused about is like if it's the conventional current flow and you would use your right hand for that. For
Yeah.
example, if your like protons are moving like left instead of right, so like how would that visually look?
Uh, so I just put this arrow. This is the direction of the current, conventional positive charges. That's all you need to know, right? And to put your thumb in that direction. I'm not sure how would you say visually? I'm not sure.
No, I mean like when you're like wrapping it around like a pen, for example. Like, yeah.
Okay, say it again. I couldn't hear you well. When I do what?
So like if the current is going like to the like right and you're using the right hand rule, so like how would that look like? That's what I
So this
mean.
is current is going kind of right, yeah? Put my thumb into that direction. Now behind, okay, you need to perform it. Put your finger to the right. Now your forefinger, if your thumb is in the right, your forefinger will go up at the back of the wire and go down in front of the wire. Did you try?
Okay, yeah, I get it. So you're just like for this one, your palm would be like facing you, kind of like that, right?
Uh, yeah, kind of. So you don't need to pay attention to palm, but yeah, it's kind of palm is up, and then you bend your finger, right? And bending your finger means in front of the wire. Your finger go down means the magnetic field in front of the wire go down. Your forefinger will tell you the direction of the magnetic field, kind of. By bending that, you will see that directions.
Okay, thank you.
Okay. Everyone need to try this. Your thumb going into the page, your forefinger need to go clockwise. Can you do that and perform this? Second one, You have your wire, your thumb going out of the page, so your forefinger going counterclockwise. Everyone need to try that and confirm. Want? Need more explanation? Turn on your mic.
So, Miss, like for example, you know the drawings that you drew, and like there's the arrow. So,
Mhm.
like for example, that's the pencil, and it's like pointing upwards, and the arrows that's around it like describes if it's counterclockwise or clockwise, right?
So
And
it's not, I'm not gonna say it's go up. It's
what do you
going into the page or out of the page. So you have to have this one in front of you is like going into the page,
Mm-hmm.
right?
Yeah.
Or out of the page. So then you put your thumb in that. Actually, you have to perform it. If I say that to you, you won't get it.
Mm-hmm. Yeah.
Put your pen like this, what I do. Put your thumb into the page, into the direction of the current. Do it. Can you
Mm-hmm.
do it right now?
Yeah.
Then follow your finger, forefinger. Forefinger is bending. Is that bending clockwise or counterclockwise? If this is going, your thumb going to the page.
Um. Counterclockwise.
Counterclockwise. So you have to do it. You cannot imagine this.
Yeah. Yeah. Yeah.
It's hard to do it in your head. Do the same thing for the B, part B. Put, again, this is the wire into the page or out of the page. So your finger would be the direction of the current, which is out. Now look at the bending of your finger,
Now it goes clockwise.
counterclockwise.
Wait.
I said out of the page. Your finger is
Oh.
out of the page.
Okay. Yeah. Okay. Yeah. That makes sense.
So the finger gonna be counterclockwise. So everyone you have to do it, otherwise you won't get it. Okay. Any other question?
So for A and B, like which hand do you use for either one?
For both of them, I use the right hand because it's a conventional current. It's a positive charge. Anyone need more time to digest this? And ask question, please, if you have. Do it. That's my recommendation. Do it to figure it out. Otherwise, you cannot memorize these things. Actually, it sucks to memorize. This is beautiful things that you learn how to do this with your hand. Okay. All right, move on. So this is another example. Now I need to know the direction of the current. Can anyone tell me this is this is the magnetic field, means your forefinger being bending around the wire like that. What would be the direction of the current for A? Would it be to the right or left? Can anyone turn on the mic and tell me?
Right?
Okay, good. I need to do that, right? So I need to make sure that my forefinger behind that, see behind that is going up in front of the wire going down. So bend your finger in the way that at the back going up and in front going down. So then your thumb going to be in the right direction. So that would be the right, exactly. For part B, what would be the direction of the current? Please turn on your mic and tell me the answer. Anyone?
Isn't it left?
It is left. And the reason is that, again, you have this wire. See behind is going down and in front going up. So just put your finger that um uh in front of the wire going up and behind that going down. Now your thumb will be into the sorry left direction. Why I put that? It would be to the left, right? here. Your thumb go up, your thumb go to the left. Your forefinger go up in front and down at the back. Hope that you do that. Again, you don't do it, you won't get it, honestly. Now look at the picture C. Do you think the current is gonna be into the page or out of the page? Part C.
Into it?
Okay.
Is it?
Yes, I think so. I need to do it. Actually, okay, let me just do that. No, actually, it's gonna be also. Everyone try that. So this is my pencil. Just put that in a way that the pointing toward the screen. Now, you have to bend your finger in the direction of the magnetic field that you see, which is counterclockwise, right? Then you need to follow the direction of your thumb, which will be out of the page. Everyone can do that. Again, forefinger in the direction of the magnetic field, which is counterclockwise. You need to do it. The thumb gonna be toward out of the page. When you're talking about out of the page, you have to put a point like that. Means the current getting out of the page.
Miss, so if
This
the current is like out of the page, it means like it's going like counterclockwise, and then if it's into the page, it's like clockwise, correct?
That's true, but you have to demonstrate using, okay, the whole point is using the right hand rule because not always you will get something nicely into and out. So it could be at any angle, right? So
Okay, yeah.
this wire could be at any angle. That's why it's very important that you use your right hand rule. Tell me this. Yeah,
Wait, how do we know when to use our right hand versus
always.
left hand?
Always when you have a positive charge moving, it's going to be right hand. Negative left hand when negative charge is moving. With conventional current that we have in wire, I always say that the positive charge is moving, right? Convention.
Is it always given in the question?
Yeah, you will get a wire and you know that there's gonna be a conventional current is positive, so the right hand rule. Yeah. Otherwise, the question said that, hey, this is a charge negative moving in a magnetic field. Then you use your left hand.
Miss, so like what type of like questions would like this like topic
So this
like give
topic
us?
you would get a wire. You either have a magnetic field and you need to figure out the direction of the current, or you will have a uh, direction of the current that you need to find the magnetic field, the direction of the magnetic field around that, right? So one of that will be given and you will need to find the other. So you need to find current or magnetic direction of magnetic field, right? One of that will be given and you have to find the other one. Let's say the current will be given and then you need to find the direction of the magnetic field. Or the magnetic field will be given and you need to find the direction of the current using the right hand rules or left hand rules. But mostly I'm going to give you the right hand, right? Everyone got that? Any other questions? So here we did predict the current flow through a wire based on the magnetic field, predicted that. So means magnetic field was given and we did find the direction of the current, predicting the magnetic field around the wire based on the current. The current was given and we predicted the magnetic field direction. And don't forget to do your homework. So the next one is solenoid and the motor pylon. So I'm not gonna do that. I'm gonna leave it for the next class. Make sure you just do the homework. This one, I'm gonna cover that in next class, okay?